So direct variation. That's what we're doing. Direct variation. Okay, direct variation. Basically, this is when I have a situation where when x increases, y increases proportionally at the same time. And if x decreases, then y decreases proportionately at the same time. So if one goes up, the other goes up. If one goes down, the other also goes down. And they have the basic form y equals kx, where k is our constant of variation. So let's say I had a table, and I just am going to ask, is this a direct variation? That's all I'm going to ask. So I have x, y, and then I put 1, 4, 2, 8, 3, 11. Now notice this formula, y equals kx. The way I'm going to test to see if this is direct variation is put in my x's and y's into my formula and see if I get the same k all the time. So 4 for y equals k x. X is 1. So that would mean if I solve that k equals 4. So that's this one. This one, y equals 8, k, and 2. Divide both sides by 2 and I get k equals 4 again. And then I test the last one. Y equals 11, k, and 3. If I divide by 3, I get 11 thirds. Well, that's not 4. So no, this is not a direct variation, because when I solved for k on all of those, I did not get the same thing. Now, there is a faster way to do it. You could do 11 divide 3, 8 divide 2, and 4 divide 1 really fast, but then when we do the other variations, you might forget which way to go, because the other variation goes the other way. So I think it's better just to put it into the formula. That way you're remembering the formula and understanding that we need to get k. Yeah, my speaker is having a wonderful time by itself. This is Caroline's face when she's playing libero, or whatever it's called. Then she has a fist.
Libero or libero?
I don't know what it's called.
It's either libro or libero.
Libro.
But libro sounds like an I, not an A.
Okay, libro. Whatever. Okay, let's go on. Let's do same question. X, Y. And 1, 2, 3, 6, 4, 8. And I'm going to ask, is this a direct variation?
It is.
And yeah, it is. We can see that 2 divide 1, 3 divide, or 6 divide 3 is 2. 2 and 2. Well, let's prove it. What's our formula? Y equals kx. So 2 equals k times 1, solve for k. This one, y equals 6, k, 3. Divide by 3, k equals 2. And the last one. Okay, so I got 2 all the time, so yes, this is a direct variation. And it's a direct variation such that k, my constant variation, is 2. Now maybe I do a horizontal chart. Okay? If I multiply 3 by negative 7, I get negative 21. If I multiply 2 by negative 7, I get negative 14. And if I multiply 1 by negative 7, I get negative 7. So we'd say, yes, this one's a direct variation. I'm going to really quickly prove it. Negative 21 equals k times 3. Divided by 3, k is negative 7. I expect to get negative 7 each time. Negative 14 equals k times 2. Divided by 2, k is negative 7.
So how did you know you were going to get negative when you're looking for the negative 7?
When I was doing this, when I got right away, I just thought, how do I go from 3 to 21? Times 7. Times 7 times 7.
So the first number...
Well, negative 7. What?
So the first number that comes out should be the number you're looking for.
Yeah, if it's a direct variation, it's going to be the same thing the whole time. It might be fractional, which is why I'm saying set up this little equation thing, because it doesn't always come out nice. So, like this one. Now, I don't have to do them all. As soon as one of them is different than the others, then there's no reason to continue on. So y equals 5, k times 2, divided by 2, k is 5 halves. But if I do this one, I get y equals 7, k times 3, I get k equals 7/3. These are not the same, so this one's a no. I don't even have to test the last one. Once it fails, it fails. And all we're doing is either answering, is it a direct variation? Or I'm finding out what k is. So if it is a direct variation, I might find what k is. So in this like second one here where I said yes, k equals negative 7. K can be a fraction. That's possible as well. So that's one type of question I could ask, is it a direct variation to begin with? But maybe I'm told it's a direct variation. Okay? So I might have a question such as this one. It's not important that you copy all these examples down so much as it is to know how we got the answer for a couple of them. So here's this. We'll say y varies directly with x. So I'm told it's a direct variation. So that means, therefore, I conclude I'm using y equals kx. So y varies directly with x. Now let me finish the question. Suppose y equals 9 when x equals negative 15. What is y when x equals positive 21? So I start knowing that it's direct variation. The first couple problems that we did, we were given some information. We asked, is this a direct variation? We concluded yes or no, based upon whether k was always the same. In this case, I'm told, hey, it is a direct variation, but now I'm missing a piece of information. So I use this piece of information. Suppose y equals 9 when x equals negative 15. So I know it's a direct variation. But in order to answer this question, I need k. I need k to answer this. So I'm going to do it in two parts. Now your book shows you how to do it in a proportion, That's okay, but I'd rather you know to use this direct variation formula. Because then you're basically using the same formula all the time. So y is 9 when x is negative 15. So I just plug those in, which is actually what we just did when we asked the question. Is it a direct variation? This time we're finding k, so we divide both sides by negative 15. And I can reduce this fraction, so I get negative 5 or negative 3/5. That's k. This is not the answer. Well, why isn't it the answer? Because I'm not asked for k. What I'm asked for? I'm asked for what is y when x equals 21. So now I know k. So now I can take this and rewrite my formula, except now I know k. I know that k is negative 3/5.
Multiplying it by 21.
And now I take this 21 and say, well, I want to know y when x is 21. Now, does it come out nice? No, it does not.
Maybe 12.6.
Yep. So we get something yucky, but that's okay. We basically use the information we're given to find k, put k back into the equation, just replace it, and use the formula again. Okay? So we use the information given to get k. Now sometimes all we're asked is to find k. If that's what we're asked, we're done. But in this example, we were not. It wasn't that easy. Okay. Same setup. So y varies directly with x. Suppose y equals 15 when x equals 3. What is y when x equals 12? So since I'm told this is a direct variation, what formula do I think of? Y equals kx. I use it because I'm told that. I'm told y and I'm told x. So y is 12, k times 3. Now what do I do? Divide by 3, so k equals 4. I have found k. That's our constant of variation. So now I'm at this piece. I need to answer the question. The question asks, what is y when x equals 12?
I have a question. You put 12 as the y up here first, or is it supposed to be 15 at first?
Well, I'm a bonobo. This should be 15, which means k is 5. Thank you. Good catch.
Here.
All right, good job. Wow, that was dumb. All right, so, well, now I use this information. So y equals, now I know k is 5. Okay, when x equals 12. So I replace x with 12. I get y is 60. Very important. All direct variations have the form y equals kx. If it looks anything different, then it is not a direct variation. So if I wrote y equals 5x plus 3, there's an extra 3 there, so not a direct variation. I want to make sure I hit on graphing these so that you can do those questions if it asks you to graph them. You're going to think of k as slope. And also, this is a good opportunity to practice with your calculator. So go ahead and get those out and ready so that we're in our graphing mode. All right. Let's say I have y equals 3/4, or 3, yeah, I meant 3/4. I wrote 3/5, but 3/4 x. This is a direct variation. How do I know? It has the form y equals kx, k equals 3/4. But if I'm graphing this, I need to recall slope-intercept form. These are always going to be lines. Slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. But in the case of direct variation, so for direct variation, y-intercept is always, very rarely will I say always, y is always 0, the y-intercept. So that b, that y-intercept will always be 0. So if I'm graphing this, I'm graphing it, m is 3/4, which means up 3, right 4. And my y-intercept, or my b, is 0. And for a direct variation, that's always going to be the case. So let's say I'm graphing this. I'm going to switch to my graph. I'll come back to that slide so that you can finish it. Here's my graph. We said our y-intercept is 0. That's right there at the origin. I go up 3, change in y over change in x. Remember slope, change in y over change in x. So we actually deal with our y's first. Up 3, right 4. Up 3, right 4. Always go left to right at first. And then we draw our line. And hopefully it goes better than that just did. Okay, so I got one of my points messed up somehow.
You have 2 and right 4.
Oh, yeah. Thank you. Thank you. Should have been like right there, right? And then we put arrows at the end of our lines. And this is the line y equals 3/4 x. Which, just as a note, just so that you know, when you see this, it means the same as this. Those are the same. This means 3/4 times x. This means 3x divided by 4. Same thing. So if you see x over 2, you could rewrite that as a half x if you wanted. Let's do another graph. Let's do 2 more graphs. And I'll go back, yes. We'll do 2 more graphs, and then I want to do some more finding k. All right, I'm going to go on to my other 2 graphs. I'll give you like 30 seconds here on this one. So we're going to graph 2 others. I'll just go ahead and use this slide. We're going to graph y equals negative 2x over 3, and y equals, we'll say 3y equals x. All right, so this first one, so we're down here. Remember, this is the same as saying y equals negative 2/3 x. So what's my y-intercept? 0. And I'm going to go down 2, right 3. So I'm going to erase all this. Get that out of the way. started at the y-intercept, I'm going to go down 2, right 3. Down 2, right 3. And then I extend my line with my ruler. With the ends, the arrows, and that's the line. Y equals negative 2/3 x. So what's k? Negative 2/3.
So what was with the 3y equals x?
Yep, so let's do that one. The other one was 3y equals x. Notice that I in order to graph this, or even to know if it's a direct variation, I solve for y. So we get y alone. So we divide both sides by 3. And I get x equals, now this is the same as 1/3 x. So my y-intercept is, and I'll do this in green again, except my line will be green. I start at the origin, but I go up 1, right 3. Up 1, right 3. Connect. Use my ruler to extend. Arrows at the end. And that's y equals 1/3 x. So what's k? 1/3. I don't want you to copy the following problems down. I just want you to follow along. So assume y varies directly with x. So I'm not going to write that 100 times. So it's direct variation. So y equals 6 when x equals 2. X equals blank when y equals 12. Okay, so here's two problems. I'm told it's direct variation, so I use y equals kx. Y is 6. X is 2. I find k. K is 3. Now I use y equals kx again, except now I know k is 3. I use this information. I don't know x, but I know y. Y is 12. What do? Divide by 3. So x is 4 when y is 12. This one starts the same. Y equals kx. How do I know? Because it's direct variation. Y equals 5. K times negative 3. I divide by negative 3, and I get negative 5/3 is k. That's not the answer unless it asks for k. It might say, find k. In that case, you're done. But I'm asked for y when x equals 3. So I go back to my formula. K is negative 5/3 x. I replace x with its equal. And you can use your calculator to help if you need. But in the end here, after cross-canceling, I get positive 5. So that's my answer. All right, the very last thing. Okay, so you'll want to write these down. Maybe you're just given a point. I'll do 3. That's fine. So I'm told to write a direct variation. Well, remember, y equals kx. So what do I need to know? I need to know k, right? So I'm told to write a direct variation. So I know y. Y is negative 7. I know x. See, x, y. I don't know what? K. So I solve for k. I put in x and y, and I get k, and it's 7/3. So what's my answer? 7/3? No. I'm told to write the direct variation. So y equals 7/3 x. That's my answer, the whole formula. So the next one, I know x is negative 0.1. I know y is 0.5. See, x, y. I put those into my direct variation. I'm told to write a direct variation. I divide both sides by negative 0.1. Now, I do not want to ever see as final answers a decimal over a decimal. Use your calculator and divide it. What's 0.5 divided by 0.1? Negative what?
5.
Negative 5. So that's k. I'm not done. It said to write the direct variation. So y equals negative 5x. It might come out to a decimal or a weird fraction. That's okay. You get what I'm doing? It's just the same formula over and over and over again. It's just a variety of different questions to answer it. So y is negative 1, x is 9, divide by 9, and k is negative 1/9. That's fine. And I don't want to write that as negative 0.1 repeated. Y equals negative 1/9 x. Done. And hopefully you saw a shortcut. Y divide x, y divide x, y divide x every single time. Okay? But it's the same formula over and over and over again. Alright, so we will stop there. Turn your